In this video, we're going to talk about the difference between instantaneous velocity and average velocity. So average velocity, which is a vector, is equal to delta x over delta t, the displacement over time. And instantaneous velocity, which just gets the symbol v, is equal to the limit of the average velocity as the time goes to 0. So, in other words, using a smaller and smaller time interval allows us to get instantaneous velocity. Well, let's go ahead and look at this in terms of this example here of the girl running up and down a sidewalk in front of her house. And so here's the graph of that motion, where it's position versus time. And the first question, is this one or two-dimensional motion? We're going to draw a little diagram here. So the blue line represents the sidewalk in front of her house, and we'll call this 0. And then we'll say that this is where her mailbox is. Okay, so there's where her mailbox is, but she doesn't start at 0. She starts off at point A, standing about 5 meters away. She proceeds to move until she's about 10 meters away, maybe a little bit more. We'll just call it 10 meters. And that's at point B. Then, by point C, she's back to where she started. And then at point D, now she's at 0 meters, which is where we said her mailbox was, just as a point of reference. That's where all the measurements could have been made from. And then at point E, she's gotten to be negative 5 meters away. And by point F, she's about negative 10 meters. In other words, 10 meters to the left of her mailbox. And then at point G, she's gotten back to where she was at point E. And then at where the last numbered point is at H, and she's back to her mailbox, and then she keeps going past it. So is this one or two-dimensional motion? Well, it's one-dimensional motion. She went to the right, and then she went to the left, and then she went back to the right. So that is one-dimensional motion. Even though the graph, you're like, wait a minute, look at this. This is 2D motion. No, that's a graph of position versus time. That is not showing what the sidewalk looked like in front of her house. What is the average velocity of the girl from point A to point C? Well, for that, we need delta x over delta t to give us the average velocity. And so that's 5 meters minus 5 meters over, well, whatever time period it was, doesn't really matter. And so it's 0 meters per second. Yes, she did move, but her average velocity is based on delta x, and her delta x was 0. Now, is the average speed equal to the average velocity for this time period? The answer to that is no, because average speed is based on distance traveled over time, and the distance that she traveled was about 10 meters. She went from 5 meters to 10, that's 5 meters, and then 5 more meters, so she traveled a total distance of 10 meters. And I'd say it took about 1.3 seconds. So if we calculate that, we get about 7.69 meters per second. And so we're showing that in terms of a calculation that they're not equal. We can say also, no, they're not the same, because speed is based on distance traveled, while velocity is based on displacement. That's the difference. All right, is there a time period between A and D when the average velocity is positive? Absolutely. If we look from A to B, the average velocity is positive. The final position, okay, remember delta x is x minus x naught, where x represents the final position, x naught represents the initial position. So 10 minus 5 gives us a positive number. So that's going to give us a positive velocity. Is there any time where the average velocity is negative? Absolutely. If we look from A to B, no. A to C, it's 0. A to D, though, 0 position minus 5. So A to D has a negative displacement and also a negative average velocity. But that's not the only one. From B to C, B to D, or C to D, all of those are also going to give us negative displacements and negative velocities. Okay, and feel free to calculate each one of those using this for delta x and knowing that this is how you calculate average velocity. All right, when is the girl moving fastest? Between points B and C or between points C and D? And to do this, we could do the calculations, but I really want you to be able to see it on the graph in terms of the slope. And to help you with that, take a look at this green line here and you can see that slope. We know that slope equals rise over run. And it's not actually a rise here because it's going downhill. That just means that's going to be a negative number. But we also know that rise is the delta x, that's the change in position, and the run is delta t. And then we know that delta x over delta t is the velocity. Okay. And then we look at the slope between C and D. This line's a little bit harder to see, but you can tell that the line from C to D has a greater magnitude slope. They're both negative, but the steeper slope is from C to D. So C to D, because that line is steeper and slope of position versus time represents let's say how fast an object is moving. At which lettered point or points is the object moving fastest? Okay, well, we're going to treat this as a sine wave, sinusoidal curve here. And you don't need to know about sinusoidal curves for this class, but by saying that, I'm just saying that the slope of this is always changing. Even though it does look fairly constant from C to E, I'm treating it as if it's a sine curve, and so it's a certain slope here, and then it gets steeper, and then it gets steeper, less steep, less steep, less steep. So we're looking at it from that perspective. So the difference as we go from average velocity to instantaneous velocity is just a matter of making delta t smaller and smaller. And so if we make delta t so small that the line, if we were able to draw a straight line, so it just touched the graph at one point, that would be a tangent to the graph. And so we can think about the tangent at all these different points along the line. You can hold a piece of paper up to the screen or a pencil or something and hold it so it just lines up like that, and then move it. And so when it's here, it's kind of like that. And then over here, your piece of paper or your pencil's just barely touching right there. And that tells you what the velocity is at any given point. So when is the slope the steepest? And on this, it starts off fairly steep, gets less and less steep. Then there's zero steepness there. And now it's getting steeper and steeper and steeper all the way to point D. So point D is when it's moving fastest. Then it gets less and less steep. And then it gets more and more steep through here. And then at point H, it's also very steep. When is the object moving to the left? Well, let's see. From 5 to 10, she was moving to the right. But from here to here, she was moving to the left. And then from C to D, she was moving to the left, and D to E. But we're supposed to do it just for specific lettered points. So C, D, and E, at all of those points, she's moving to the left. And for all of those, we know that she has a negative velocity. If we were to draw a tangent line right here, it has a negative slope. Tangent line there, negative slope. Tangent line there, also a negative slope. When is she speeding up? we would say at point C, she is speeding up. At point D, that's her fastest moment. So after that, then she's starting to slow down. Oh, and so we can put that in. So she's slowing down at point E. And then after F, she starts to speed up again, speeding up, speeding up, speeding up. And then fastest at H. So at G, she was speeding up. And then we go wrap around to the beginning. And so it must be at A. From A to B, she's slowing down. So point A is the beginning of the slowing down part. And then from B, at points B and F, that's when she's turning around. So the slope of the position versus time graph is equal to the velocity, because the slope has a positive or negative associated with it, just as velocity does, because velocity is a vector. And in this case, positive meant moving to the right, and negative meant moving to the left. Hope that this helps you understand instantaneous and average velocity just a little bit better.